Welcome to all. Myself Satya Chowdary, Assistant Professor, ECE Department. In this lecture, I am going to explain the analog modulation techniques. So, introduction, elements of communication system. What is the meaning of communication? It is the process of conveying or transferring information from one point to another point, or transferring the information from the transmitter to receiver, or it is a process of establishing connection or link between 2 points for the information exchange. The main block diagram of communication systems are information source, transmitter, channel, receiver, destination, and noise. First block of the communication systems are information source. The message or information to be communicated and originated in the information source. Message can be word or grouping of words, code, data, symbol, signal, anything. Next, second block of the communication systems are transmitter. The main objective of the transmitter block is to collect the incoming message signal and modifying it and suitable for the given information are transmitted via channel. Next block of the communication system is channel. Channel is nothing but a physical medium which converts the transmitter that data into the receiver, that data transmitting into the receiver. The physical medium includes copper wires, coaxial cables, fiber optic cables, waveguides, free space, or atmosphere. Next block of the communication systems are receiver. The receiver block receives the incoming modified version of the message signal from the channel and the process. It creates the original from non-electric form of the message signal. Next, what is the meaning of signal? Signal is nothing but a physical quantity which varies with respect to time or space or independent or dependent variables, or it is an electrical waveform which carries information. For example, message signal M of t is nothing but a message signal. This message signal is represented with a cos omega t plus pi. A is nothing but a amplitude or voltage of the given message signal. Omega is nothing but a frequency. It measures in radians per second. Pi is nothing but a phase of a given message signal. So types of signals. Signals is classified as two types, continuous signal or analog signal. Next one is equal to the digital signal, analog or continuous signal. If the amplitude of the signal is continuously varies with respect to time, or if the signal contains a infinite number of amplitudes, is called the analog or continuous signal. So a continuous signal is nothing but a continuously varied with respect to time. Next one is equal to the digital signal. If the signal contains only two discrete amplitudes, then it is called a digital signal. With respect to communication, signals are classified into baseband signals and bandpass signals. First one, I will explain the baseband signal. If the signal contains a zero frequency or near to zero frequency, is called the baseband signal. For examples of the baseband signals are voice, audio, video, biomedical signals. Next one is equal to the bandpass signals. If the signal contains a band of frequencies far away from the base or zero, far away from the base or zero. Bandpass signal is nothing but signal contains a band of frequency far away from the base or zero. It is called as bandpass signals. The examples of the bandpass signals are AM signals, FM signals, PM signals, PAM signals, PWM signals, PPM signals. Next, message. Its sequence of symbols. Message is nothing but a sequence of symbols. Next one is equal to the information. The content in the message is called the information. It is inversely proportional to the probability of occurrence of a symbol. Information measures in bits, comma, digits, comma, nats. Next one is equal to limitations of communication system. First one is equal to technological problem. Next one is equal to bandwidth and noise problem. Second one is equal to the signal to noise ratio. So first one is equal to the technological problem. To implement the communication system, transmitter, receiver, channel are required, which requires a hardware communication system is expensive and complex. Next one is equal to bandwidth and noise. The effect of noise can be reduced by providing more bandwidth to suitable, but due to this less number of stations can be accommodated. Next one is equal to the signal to noise ratio. Noise should be low to increase the channel capacity, but it is an unavailable experts in the communication system. Next one is equal to modulation. Very important technique, modulation. It is a process of varying the characteristics of the carrier signal in accordance with the instantaneous voltages of the message signal or baseband signal is known as the modulation, or it is a frequency translation technique which is convert the baseband or low frequency signal to band pass or high frequency signal. Modulation technique can be used in the transmitter. Next one is equal to the types of modulation. The types of modulation is classified as two types: continuous wave modulation, pulse modulation. In continuous wave modulation, message signal is taken as a continuous signal, as well as carrier signal is taken as a continuous signal. Next one is equal to pulse modulation. In the pulse modulation technique, the message signal is taken as a continuous signal and the carrier signal is taken as a pulse train. Again, continuous wave modulation is classified as two types: amplitude modulation and angle modulation. Again, angle modulation is classified as two types: frequency modulation and phase modulation. Next, pulse modulation. Pulse modulation techniques is classified as two types: analog modulation technique, digital modulation technique. In analog modulation technique, again classified as three types: pulse amplitude modulation, pulse width modulation, pulse position modulation. Next, pulse digital modulation is classified as two types: pulse code modulation, delta modulation, adaptive delta modulation. First, I am discussing about the continuous wave modulation. In continuous wave modulation, first type is a amplitude modulation. Amplitude modulation means amplitude of the carrier signal varied in accordance with the instantaneous voltages of the message signal or modulating signal. Next one is equal to frequency modulation. Frequency of the carrier signal varied in accordance with the instantaneous voltages of the message signal. Next modulation is nothing but a phase modulation. Phase modulation means phase of the carrier signal varied in accordance with the instantaneous voltages of the message signal. Next one is equal benefits or needs of modulation. What is the needs of modulation? Needs means to reduce the length or height of the antenna for multiplexing purpose, for narrow banding, or to use the antenna with a single or same length, to reduce the noise effects in the transmitters and receivers, to avoid the equipment limitations or reduce the number of components and size of the equipment. Next one, first I am going to explain the amplitude modulation technique. Amplitude modulation technique means the amplitude of the carrier signal varied in accordance with the instantaneous voltages of the modulating signal. So you have taken as a in modulation means amplitude modulation you can taken as a two input signals. One is equal to message signal, second one is equal to carrier signal. In message signal is a low frequency signal. The amplitude of the message signal is AM. The frequency of the message signal is FM. Then second signal is a carrier signal. Carrier signal means high frequency signal. The amplitude of the carrier signal is AC and the frequency of the carrier signal is FC. Next, the amplitude modulated signal contains a mixing of amplitude of the message signal and carrier signal. The amplitude modulated signal contains a amplitude is equal to AC plus AM and frequency is equal to FC plus FM. The carrier signal can be represented by C of T. C of T is equal to AC cos omega CT AC is nothing but a amplitude of the carrier signal. Omega C is nothing but a angular frequency of the carrier signal. Omega is nothing but a 2 pi fc. Then you can next signal is message signal. Message signal is represented with x of t. X of t is equal to am cos omega mt. Am is nothing but a amplitude of the message signal or baseband signal. Omega n is nothing but a angular frequency of the baseband signal or message signal. The standard equation of the amplitude modulation is the standard equation for the amplitude modulated signal is expressed as S of t is equal to AC cos 2 pi fct into 1 plus MA cos 2 pi fmt. AC is nothing but a amplitude of the carrier signal. FC is nothing but a frequency of the carrier signal, and MA is nothing but a modulation index. Modulation index is nothing but a ratio of amplitude of the message signal to the amplitude of the carrier signal. Then MA means modulation index is equal to AM divided by AC. Next, I will discussing the time domain representation of AM. The amplitude modulated signal S of t is equal to AC cos 2 pi fct plus mu AC by 2 into cos 2 pi fc plus fmt plus mu AC by 2 into cos 2 pi fc minus so ST is equal to AC cos 2 pi fct plus mu AC by 2 cos 2 pi fc plus fmt plus mu AC by 2 into cos 2 pi fc minus fmt. In this amplitude modulated signal contains a three terms. First term is nothing but a carrier signal with amplitude AC and frequency fc. Second term is amplitude is equal to mu AC by 2. Frequency is equal to SC plus FM. FC plus FM is contain a upper sideband frequency. Next one is equal to the third term. Third term amplitude is equal to mu AC by 2. Frequency is equal to SC minus FM. FC minus FM is represented with lower sideband frequency. Next, frequency domain representation of AM. The time domain can be represented by S of t is equal to AC cos 2 pi fct into 1 plus MA cos 2 pi fmt. Taking Fourier transforms on both sides. S of t Fourier transform is S of S. Then Fourier transform of amplitude modulated signal is AC by 2 del of FC f minus fc plus del of f plus fc plus AC MA by 2 into m of f minus fc plus m of f plus fc. So the first signal is represented with a frequency representation of message signal. Message signal contains a amplitude is equal to m, upper frequency is equal to fm, lower frequency is equal to minus fm. Next, the amplitude modulated signal in frequency domain. The upper sideband frequency is fc plus fm. The lower sideband frequency is fc minus fm. Carrier frequency is fc. Next, modulation index. Modulation index is also known as the depth of the modulation. The depth of the modulation means the ratio of amplitude of the message signal to the amplitude of the carrier signal is nothing but a depth of the modulation or modulation index. You can find out a percentage of modulation means AM by AC is multiplied with the 100. Types of amplitude modulation with respect to modulation index. Depending upon the modulation index, the amplitude modulation is classified as three types. Under modulation, less than 1, modulation index is less than 1. Next one is equal to critical modulation. Modulation index is equal to 1. Next is nothing but a over modulation. The modulation index is greater than 1. So first signal under modulation. Under modulation means the modulation index is less than 1. Means AM by AC less than 1 or AM less than AC. So under modulating signal, the amplitude is equal to AC and negative amplitude is considered as minus AC. Next one is equal to critical modulation technique. Critical modulation is nothing but the modulation index is equal to 1 means amplitude of the message signal to the amplitude of the carrier signal is equal to 1. Then it's equal to AM is equal to AC. Next modulation is over modulation technique. In over modulation technique, the modulation index greater than 1, the modulation index greater than 1, then AM by AC greater than 1, AM greater than AC. Next one is equal to generation of AM wave. The generation of AM waves is classified as two types: square law modulator and switching modulator. In square law modulator consisting of three blocks. First block is non-linear device. Next one is a band pass filter. Next one is carrier source or modulating signal. The inputs of the modulating signal and carrier signal is applied to the non-linear device. Next one is equal to band pass filter. So the modulating signal or carrier signal connected in series with each other, and there some V1. V1 is applied to the input of the non-linear device. Such as non-linear device is nothing but you can use as a diode or transistor. Then input is equal to V1. V1 is nothing but a adding of message signal to the carrier signal. Message signal is represented with X of t and carrier signal is represented with AC cos omega ct. Next, the input output relations of the non-linear device means you can use as a non-linear device is diode or transistor. The input output characteristics of the diode or transistor, V2 of t is equal to A into V1 of t plus B into V1 square of t. In this equation, V1 is nothing but a input signal. Input signal means message signal is added with the carrier signal. These message signal added with the carrier signal is substitute in this non-linear device input output relations. Then V2 of t is equal to A into V1 means X of t plus A into AC cos 2 pi FCT plus B X square of t 2 into B into X of t AC cos 2 pi FCT plus B into AC square cos square 2 pi FCT. In this above equation is passes to the above signal is passes to the band pass filter. This band pass filter passes the certain band of frequencies and eliminate the sum of the frequencies. In this above signal contains a 5 terms, 1, 3, 5 terms are unusual terms. The band pass filter eliminates the 1, 3, 5 terms. The output of the band pass filter V0 of t is equal to A into AC cos 2 pi FCT plus 2B X of t into AC cos 2 pi FCT. This signal is nothing but a amplitude modulated wave. Next generation of the amplitude modulated wave by using the switching modulator. In switching modulator, you can contain the X of t and C of t. X of t is nothing but a message signal and C of t is nothing but a carrier signal. The X of t and C of t connected series with the diode. So the carrier signal C of t is connected in series with the modulating signal. The sum of two signals is passes through the diode. The output of the diode is passes through the band pass filter. The resultant output of the band pass filter is AM wave. Then input V1 of t is equal to X of t plus C of t. The amplitude of the C of t must be greater than X of t. So then the diode is on or diode is off. When C of t, when the carrier is positive, then V2 of t is equal to the V1 of t. When the carrier signal is negative, V2 of t is equal to 0. Finally, V2 of t is equal to V2 of t is equal to M of t by 2 plus AC by 2 into cos omega ct plus 2 by pi into X of t cos omega ct plus 2 by pi into AC cos 2 pi omega ct. Next one is equal to detection of AM waves. Detection or demodulation. Demodulation or detection is a process of recovering the original message signal from the received modulating signal. The input of the detection is a AM wave. The output is nothing but a baseband signal or message signal. The detection of the AM wave by using the two methods, square law detector and envelope detector. First, I am going to discussing the square law detector. This one is a block diagram of square law detector. Square law detector containing a square law device. Next one is equal to the low pass filter. So input is nothing but a AM wave. AM wave is represented with V1 of t. The amplitude of the modulated wave is given to the input to the square law device. The square law device is nothing but you can use as a diode or transistor. That then V2 of t is equal to A into V1 of t plus B into V1 square of t. This equation is nothing but a input output relations of a diode. When the signal is passes to the square law device, then V2 of t is equal to A into AC cos omega ct plus A into AC m of t into cos omega ct plus B into AC square into cos omega ct plus B into AC square m square into cos square omega ct. This signal is nothing but a output of square law device. This output of the square law device is passes to the low pass filter. This low pass filter only allows the low frequencies. Then output of the low pass filter V naught of t is equal to m into b into AC square into x of t. MB AC square is nothing but a constant. X of t is nothing but a message signal. Next detection of the AM wave is envelope detector. So this one is a block diagram of the envelope detector. In envelope detector, you can use as a RC circuit as well as a diode. The input is nothing but a AM wave. AM wave is nothing but S of t is equal to AC cos 2 pi FCT into 1 plus MA cos 2 pi FMT. So the standard AM wave is applied to the input of the detector. In every positive half cycle of the input, diode is in forward bias. When capacitor the capacitor charges. When the capacitor charges to peak value of the input voltage and diode stop the conducting, the capacitor discharges through R between the positive peaks. This process is continuous under capacity is charging and discharging rapidly. This capacitor is charging and discharging rapidly. Next one is equal to the, so this one is equal to the detection of the AM wave. In detection of the AM wave, you can take an as a AM signal. This one is equal to AM signal. In first case, diode is in on. Next case, diode is in off position. Next diode is in on position. Next diode is in off position. You can connect the all peak values. You can connect the all peak values to detecting the message signal. To detecting the message signal. Next, I am going to discussing the double sideband suppressor carrier modulation, means DSP-SC modulation. The equation of the AM wave is in the simple form. S of t is equal to AC cos omega ct plus AC by 2 into cos omega c plus omega mt plus AC by 2 into cos omega c minus omega t. Here, amplitude modulated wave contains three components. First one is equal to carrier component. Next one is equal to the upper sideband component. Next one is equal to lower sideband component. The above AM wave, the carrier components remains constant and does not carry the any information. Therefore, if the carrier is suppressed, only sidebands remains in the spectrum requires the less power. The definition of DSP-SC modulation means the process of suppressing the carrier signal from the amplitude modulated wave is nothing but a double sideband suppressor carrier wave. Double sideband suppressor carrier contains a two sidebands, that is upper sideband and lower sideband. The power efficiency of the DSP-SC wave is 100%. The percentage of power saving in DSP-SC with respect to AM is 66.6%. The DSP-SC modulation. The DSP-SC signal is obtained by multiplying the modulating signal with the carrier signal. Means S of t of DSP-SC is equal to M of t into C of t. So we need a product modulator for the generation of DSP-SC wave. First, you have to generation of DSP-SC wave by using the product modulator. In product modulator, the inputs are the message signal and carrier signal. Then the output of the product modulator is DSP-SC wave, means multiplication with the message signal to the carrier signal. Next one is equal to generation of DSP-SC wave. Generation of DSP-SC by using the two methods. First one is equal to the product modulator technique. Next one is equal to the balanced modulator technique. In product modulator, You can use as a one product modulator. The input of the product modulator is message signal and carrier signal. Then the output of the product modulator is DSP-SC wave. Is contains S of t is equal to X of t into C of t. Next generation of DSP-SC is balanced modulator. It contains a two amplitude modulator arranged in a balanced condition to suppressing the carrier component. In this block diagram, upper is nothing but a one amplitude modulator. Next lower is nothing but a one amplitude modulator. Both are in balanced condition. The carrier signal is C of t is applied to the both modulators. The message signal X of t is applied directly to the modulator 1 and phase shift 180 degrees is applied to the modulator 2. Then the output of the modulator 1 S1 of t is equal to AC into 1 plus M X of t into cos 2 pi FCT. The output of the modulator 2 is nothing but S2 of t into AC into 1 minus M into X of t cos 2 pi FCT. These S1 of t and S2 of t is passes to the summer point or summer. Then output of the summer junction is DSP-SC. Then S of t is equal to S1 of t plus S2 of t. Then you can produce a DSP signal. Next generation of DSP-SC by using the ring modulator technique. This one is nothing but a ring modulator technique. In ring modulator technique, you can use as a 4 diodes of 2 diodes in forward bias, 2 diodes in reverse bias. You can use as a center tap transformer. One of the transformer input is message signal. The center tap transformer center terminal is connected to the one signal. Then output of the center tap transformer, second center tap transformer is DSP-SC. It is operated in two modes. First mode 1 is equal to without modulating signal X of t. Next mode of operation is nothing but a with modulating signal X of t. Mode 1, C of t, carrier signal is positive. Carrier signal is positive. You can applying a carrier signal is positive. Diode 1 and diode 2 are the forward bias. And the diode 3 and the diode 4 are the reverse bias. The output of the ring modulator will be 0. The output of the ring modulator will be 0. Second case, you have to applying a C of t is negative. Then you have to applying a C of t is negative. C of t is negative. The diode D1 and D2 are the reverse bias and D3 and D4 are the forward bias. Then output of the ring modulator will be 0. In second mode of operation, when the modulating signal is present during the positive half cycle D1 and D2 on position and T1 is directly applied to the primary of the T2, then the output is equal to positive. So the message signal is represented with X of t is equal to AM cos 2 pi FMT in DSP-SC. The carrier signal of the ring modulator is represented with C of t is equal to AC cos 2 pi FCT. The DSP-SC signal S of t is equal to X of t into C of t. Then S of t is equal to 1 by 2 AMAC, 1 by 2 into AMAC cos 2 pi FC plus FMT plus cos 2 pi FC minus FMT. In this DSP-SC signal contains a two components. One is equal to upper sideband component and second one is equal to the lower sideband components. Frequency domain representation of the DSP-SC. The frequency spectrum of DSP-SC obtained by applying a Fourier transform on the DSP-SC signal. Then Fourier transform of the S of t is equal to S of f. Then the Fourier transform of the DSP-SC signal means Fourier transform of the C of t into M of t is nothing but 1 by 4 into AMAC del of f plus fc minus fm plus del of f plus fc minus fm plus del of f plus fc minus fm plus del of f plus fc minus fm. The spectrum of DSP-SC contains a one upper sideband and one lower sideband. Then upper sideband is nothing but a fc plus fm. Then amplitude is equal to MAV by 2. Then the lower sideband fc minus fm. Then the amplitude is equal to MA into V by 2. demodulation of DSP-SC wave contains here two methods. First method is equal to coherent detection. The coherent detection contains a two blocks. Main block is product modulator and low pass filter. The modulating signal X of t is recovered from the DSP-SC wave. DSP-SC wave. S of t is multiplying with the local generating carrier and passing to the low pass filter. This one is equal to product modulator. The input of the product modulator is S of t, means DSP-SC wave, and one carrier signal is applied to the product modulator. The output of the product modulator is V of t. V of t is nothing but DSP-SC wave is multiplied with the carrier signal. This signal is passes to the low pass filter. This low pass filter allows only the low frequency signals. Low frequency signal is nothing but a message signal. So V of t is equal to S of t into C of t. This V of t is equal to output of the product modulator is equal to S of t into C of t. S of t is nothing but a DSP-SC signal and C of t is nothing but a carrier signal. The substituting 2 and 3 in first equation means V of t equation, then M of t is equal to something. This something means 1 by 4 into VMVC cos 2 pi FC plus FMT plus cos 2 pi FC minus FMT. The signal is passes to the low pass filter, then allows only the low frequencies. Then the output of the low pass filter V0 of t is equal to 1 by 4 into VM VC cos 2 pi FMT. Next. Thank you.